Okay, so this is problem set 8, the spring force one, or yes, spring forces, I think it's called. And then this is number 4 and 5, right in the same video, because number 4 is not going to take a long time to explain. So we have a student uses a force probe to exert varying forces on the ends of vertical springs A, B, and C. The student then sketches the magnitude of the applied force as a function of the length of the spring for each spring shown. Which of the following correctly compares the spring constants of each spring? So let's just look at the setup here. We'd have a vertical spring, then we'd have an FA applied by the student. Maybe they are taking, we don't know exactly how they're doing this, whether they're putting specific forces on it of like 10 newtons, 20 newtons, 30 newtons, and then measuring the length, or if they're seeing how much force it takes to stretch it 1 centimeter, how much force it takes to stretch it 2 centimeters. But it's one of those two. Then what they're going to do is they're going to graph their work. And when we take a look at our equation for spring force, we have the spring force is equal to negative K, and it's delta X, right? Well, in this situation, we're actually not measuring the spring force, we're measuring the applied force, which will be the opposite direction of this, so it will be a positive K, and instead of X, we're gonna put an L. And this is what's on the Y-axis, the F applied, and the length is what's on the X-axis. So guess what, folks? K is gonna be the slope. Or you could go ahead and think of it as rise over run. And I just look at how steep the slopes are. The steeper the slope, the greater the spring constant. Okay, so when I do this, I see that A is obviously the highest one, which does give me the correct answer of D. However, B and C look the same to me. So I'm just going to tell you what I did to make sure I was correct on that and I wasn't doing something wrong. I just put a line over B and then moved it over to C and saw that indeed B was steeper than C. And then we have answer choice D. All right, moving on to number 5. We have our problem. Okay. So I've already done this problem, so because otherwise I think it would take me a long time to have to write everything out. So I'm just going to go through it. If at any point you want to like pause it and try to do it yourself, I think that would be a really good thing for you to try to do. Be like, oh, okay, I see what she's doing. Let me try the algebra on my own. Please keep in mind that this is not a math class. This is a physics class. So I'm here to teach you what the physics is. And in your math class, hopefully concurrently, you're starting to get those skills that are going to help you do the math that goes with the physics. All right. So taking a look, we have the vertical spring. Oh, I did not know that was going to highlight. Hold on. We have a vertical spring is attached to the floor as shown in figure 1. An object of mass M1 is placed on top of the spring and slowly lowered. That's showing us that it's not going to oscillate up and down, compressing the spring a distance x1 from its unstretched length until it reaches equilibrium, as shown in figure 2. Next, an object of M2 is placed on top of the first object and slowly lowered, compressing the spring, and this is where the word that we needed to focus on for this problem, that if you were so close but didn't get it done, is an additional distance x2. The system is again in equilibrium in figure 3. Which of the following relates x2 to x1? So in figure 2, for each of these, I drew a free body diagram. I knew that would really help me out because in both scenarios, the objects are in equilibrium, which means that the net force in each situation is 0. So in figure 2, I went ahead and I wrote an mg down. And I did try to put an equal amount of Fs going up. It might be a little short, but hopefully you get the idea. And Fs is equal to K delta X. Now, I did put a negative here because the arrow shows the direction that it is. And it's opposite of the force that was applied to stretch it. The force that was applied to stretch it was down. And the force of the spring then is up. Cool. Moving over here to figure 3. We have added mass, so instead of M1G, it's M1 plus M2G going down. So I did make this longer to try to show that. It's not exactly double, but, you know, and we don't have a grid here, so it doesn't have to be perfect. The thing that students miss here is that going up, they will just end up putting like Fs2 is equal to K times delta X2, because it's the only thing that's shown in the picture, right? But they're sneaky because M1 pushed it down delta x1. This is another delta x. So we have delta x1 and delta x2. So our spring force for the third figure is K times delta x1 and delta x2. That seems to be the thing that students miss here when doing it, in addition to the algebra that comes with this. So both springs are at rest. How do I know that? Well, it says that they are slowly lowered. And the system is again in equilibrium. So the fact that it's again in equilibrium is going to mean that it's at least moving at a constant velocity. But in this situation, we are going to say that they are at rest, because if they were moving, they would be bouncing and be in everything but equilibrium. So we go ahead and I just do the sum of the forces in the y direction for both my figures. And I have going up minus going down. So I have kx1 going up and mg going down. So k delta x1 minus m1g is equal to 0. And then my other one says the sum of the forces in the y direction is equal to k times both of the things going up, and then m1 plus m2 times g going down. So I have that going ahead. And then again, this equals 0 because, I'm sorry, it's because the object is at rest then. Okay, so the problem is that if I just start to do random things, which is actually what I did the first time, I realized about halfway through that I didn't even know really what I was solving for. So all the problems are solved for, all the answer choices are solved for delta x2, or the problem asks, how do we correlate x1 and x2? But when I take a look, I just need to make sure that I don't have any variables that the problem doesn't have. So when I look at the problem answers, I see that there is no answer with K. There's also no answer with G, but I'm just going to go ahead and decide I can pretty easily get rid of K. So I look at my answer choices, none have K, so solve one for K, so either this one or this one, and then substitute it into the other. All right, hopefully you're familiar with this math practice of substituting using another equation. So I'm going to go ahead and for my sum of the forces in the y direction for figure 2, I solved that for K. So I just rewrote the equation down here and I solved for K. I got m1g divided by delta x1. Then I substituted this in for K. Now, personally, I think that you should pause the video here and try to go from here and see, like after the substitution of K, and see if you can get the final answer on your own. Because again, that's the algebra of it, not the physics of it. But algebra is a part of physics. So you do have to shine up that skill, or you have to improve that skill if that's something you struggle with. But right here, I just wanted to show you my G's do cancel because I have a G on the left-hand side and I have a G on the right-hand side. So now I'm golden. I have no G. I have no K in my problem. So I can go from there. All right. So what I'm going to do, I'm just going to go through what steps I did take. And hopefully you've tried this on your own at this point. So now I've put this in, m1g over delta x1. I put that into K. And so instead of K, I have m1g over delta x1. My G's did cancel on the side, as I just stated. Then I'm going to distribute this m1 over delta x1 into my quantity of delta x1 plus delta x2. When I do that, I see I get m1 over delta x1 multiplied by delta x1 plus m1 over delta x1 times delta x2. And as you see, I've canceled out my delta x1s in the left part of the left-hand side of the equation. And I just haven't done anything over here. I just have m1 plus m2. So now what I'm going to do is so what I have done, I actually did do 2 steps at once. Hopefully you can follow. Once these are gone, and I'm actually going to erase them because they did go ahead and cancel. What I did here is I had m1 plus m1 over delta x1 times delta x2, and I subtracted m1 on both sides. So because I subtracted m1 on both sides, it went away over here. And on this side, I end up seeing that I have an m1 plus m2 minus m1, so these m1s canceled out. Now, what I have is I have M2 is equal to M1 times delta X2 over delta X1. And I know I'm looking for, what am I looking for? I want to remind myself because I'm so close to the end. I'm looking for that delta X2. So what I did was I took my equation, which I have here in red, and I multiplied by the reciprocal of the fraction multiplied by delta X2. So I multiplied it by delta X1 over M1, and that canceled out my fraction M1 over delta X1. And I did that on both sides, and I got this equation. All right, which is looking very similar to this. So all the only difference is that they have M2 over M1, and then they have X1, which I now realize I didn't need to draw triangles the entire time, but c'est la vie. All right, thanks for watching.